So we have an identity to prove. And I think this is another example. This is another example for the law of sines being an easy switch between sides and angles. So this is an identity that we have to prove, and A and B and alpha and beta are actually in a triangle. And there is no cosine inside. To go from A over B, that's very easy switch to swap the sides out for angles. And there is a lot of symmetry here. So this might be easier than we think. So I'm not sure which one is more complicated, but I would start with the sides and work towards the angles. So I would say the left-hand side is A plus B over A minus B. And then well, there are several things that we can do. I guess one thing we can do is divide upstairs and downstairs by B. And then we get A over B plus 1 divided by A over B minus 1. And then we can switch from A over B to sine alpha over sine beta. And now we can sort of return to the previous form by multiplying both numerator and denominator by sine beta. And that's the other side. So that was fairly simple. And there are variations. I'm going to show you another version of this, but it's pretty much based on the law of sines applied in this way. So let's say we don't have this idea of dividing by B and then switching to ratios of sines of angles. We can still say, well, I'm going to get rid of one in terms of the other. And we can say A over B or A over sine alpha. We can do either way. A over sine alpha equals to B over sine beta. And then let's get rid of B and rewrite it as A times sine beta over sine alpha. So start with the side, and this is sort of the switch that cancels out the A side, brings in the B side. And now let's write this thing, see what we get. So we get A plus B is A times sine beta over sine alpha over A minus A times sine beta over sine alpha. But you see, it's shaping up to be very much the same thing as what we did before. We can factor out A from both numerator and denominator and then cancel out and then cancel it out. And then we're going to have to multiply both numerator by denominator by sine alpha. And then we're going to get sine alpha times 1 is sine alpha, and this fraction times sine alpha. The sine alpha, we selected to knock out the denominator. And there we are. That's the right hand side. Thanks for watching.